Welcome to Video 4 for this unit on exponents and scientific notation. In this video, we're going to focus on scientific notation. The total value of all the quarters made in 2014 is $400 million. There are many ways to express this using powers of 10. We could write this as 400 times 10 to the 6th dollars, 40 times 10 to the 7th dollars, 0.4 times 10 to the 9th dollars, or many other ways. One special way to write this quantity is called scientific notation. Scientific notation is a way to write very large or very small numbers. We write these numbers by multiplying a number between 1 and 10 by a power of 10. In scientific notation, $400 million would be written as 4 times 10 to the 8th dollars. For scientific notation, the cross symbol is the standard way to show multiplication instead of the dot symbol. Writing the number this way shows exactly where it lies between two consecutive powers of 10. The 10 to the 8th power shows us the number is between 10 to the 8th power and 10 to the 9th power. The 4 shows us that the number is 4/10 of the way to 10 to the 9th. Some other examples of scientific notation are 1.2 times 10 to the negative 8th power, 9.99 times 10 to the 16th power, and 7 times 10 to the 12th power. The first factor is a number greater than or equal to 1 but less than 10. The second factor is an integer power of 10. Multiplying numbers in scientific notation extends what we do when we multiply regular decimal numbers. For example, one way to find 80 times 60 is to view 80 as 8 tens and to view 60 as 6 tens. The product, 80 times 60, is 48 hundredths or 4,800. Using scientific notation, we can write this calculation as 8 times 10 to the first power times 6 times 10 to the first power equals 48 times 10 to the second power. To express the product in scientific notation, recall that scientific notation is written by multiplying a number between 1 and 10 by a power of 10. So we would rewrite 48 times 10 to the second power as 4.8 times 10 to the third power. Comparing very large or very small numbers by estimation also becomes easier with scientific notation. For example, how many ants are there for every human? There are 5 times 10 to the 16th power ants and 7 times 10 to the 9th power humans. To find the number of ants per human, look at the quantity 5 times 10 to the 16th divided by the quantity 7 times 10 to the 9th power. Rewriting the numerator to have the number 50 instead of 5, we get the quantity 50 times 10 to the 15th power divided by the quantity 7 times 10 to the 9th power. This gives us 50 divided by 7 times 10 to the 6th power. Since 50 divided by 7 is roughly equal to 7, there are about 7 times 10 to the 6th power, or 7 million ants per person. Consider when we add decimal numbers, we need to pay close attention to place value. For example, when we calculate 13.25 plus 6.7, we need to make sure to add hundredths to hundredths, tenths to tenths, ones to ones, and tens to tens. The result is 19.95. We need to take the same care when we add or subtract numbers in scientific notation. For example, suppose we want to find how much farther Earth is from the Sun than Mercury. Earth is about 1.5 times 10 to the 8th kilometers from the Sun, while Mercury is about 5.8 times 10 to the 7th kilometers. In order to find 1.5 times 10 to the 8th minus 5.8 times 10 to the 7th, we can rewrite this as 1.5 times 10 to the 8th minus 0.58 times 10 to the 8th. Now that both numbers are written in terms of 10 to the 8th power, we can subtract 0.58 from 1.5 to find 0.92 times 10 to the 8th power. Rewriting this in scientific notation, Earth is 9.2 times 10 to the 7th kilometers farther from the Sun than Mercury. Thank you for watching video 4 of 4 for this unit on exponents and scientific notation.